So our goal when we do these is we want the left-hand side to be equal to the right-hand side. So we have to choose which side that we're going to work with to show that either the left side is the same thing as the right side or the right side is the same as the left side. So when you do these, what you have to do is you can only work with only one side of the equation at a time. And this will make sense later, but if you have a choice, it's often better to start with the side that's more complicated. Look for opportunities to either factor, add fractions, square a binomial, or create a monomial denominator. Do you guys remember what monomial means? One thing in the denominator. So for example, if you have like 1 over 2x, that's monomial, but like 1 over x plus 3, that's not monomial because there's two things. Look for opportunities to use your fundamental identities. So that big box that you guys have, pay attention to what functions are involved in the final expression you're trying to attain. So pay attention to what you're trying to get to. So highlight this. If you can, try to create sines and cosines because they pair up well, as do secants and tangents, as do cosecants and cotangents. This next one, actually, shout out to my professor at Cal State Stanislaus. His name was, this is his name. And yes, this is really how it was pronounced. But he was awesome. He was really cool. I had him, when I got to Stanislaus, guys, I started in PreCal because I didn't take calculus in high school. I took the same professor for PreCal, Calc 1, Calc 2, Calc 3, and linear algebra 5 semesters straight in a row. And so I got to know him pretty well. All my graduation stuff, he was my go-to. I TA'd for him. I got letters of recommendation from him. I got a scholarship from him, so he was the homie. But I was always stuck on these when I took trig in high school. But when I got to college, he always told us to do this, and this helped out a lot. If you have no idea what to do, try converting everything to sines and cosines, because that will help you kind of figure out what to do. All right, just like in life, don't just give up. Always try something. Please, if you have a test and you have no idea what to do, at least try this. Show me you're trying to attempt something, okay? Even if you attempt something that leads to a dead end, it might provide some insight of what you can do to try a different strategy. Now, I encourage you guys to work together, okay? Please don't just upload your homework to AI and have it do it for you, okay? Because that's not going to help you guys on your tests. But understand that if you guys are working together, you guys might do a problem in a completely different way, and that's okay. There's different ways to do these, and some of these problems will actually show you guys different ways to do these. Always keep your end goal in sight. You're trying to show that both sides are equal to each other. This is not the same as solving. The goal is to show one side is the same as the other side. Okay. So first example. Okay, so what students get confused about first is like whenever you guys solve math problems, you usually try to get like x by itself or theta by itself, right? What you're trying to show is this is equal to secant, or this is the same thing as this. So one of the first strategies you guys see in your box is to start with the side that's more complicated. Which side looks more complicated, the left side or the right side? Left side. And why? Because there's more stuff, okay? So what I want you guys to understand is it needs to be clear when you guys show your work that you're working with this side. So what you're gonna do is all your steps, don't write anything down yet, all your steps need to be vertical going down with equals like that. Because then to me, it looks like you're always on the left side, and then you're not gonna write anything on this side until you show that this is the same thing as secant. Does that make sense? So you're gonna manipulate until you get secant. And some of these problems are gonna be really short. Some of these problems are gonna be really long. Okay, just depends. All right, so let's say we have no idea what to do. Shout out to my homie professor. What did he say to do? Convert everything to sines and cosines. What is cosecant the same as? 1 over sine. So I'm gonna change this first term to 1 over sine theta. How could I write tangent using sines and cosines? Sine over cosine. Okay, now, does everyone understand that? You write equals, but then don't write anything on this side yet. Because we don't know if this is secant yet until we actually prove it. Do you guys notice something? What can happen? Sines cancel. So what's left on top? 1. What's left on the bottom? Cosine theta. And oh my goodness, what's 1 over cosine theta? So secant theta is equal to secant theta. Okay, I'm gonna let you guys have the freedom to have your little trademark. So when you're done with these problems, you just prove this. This is showing your work, this is your answer. So you can either put like a check mark, done, or you can put like a smiley face. When I was in high school, I did this. I wrote owned when I was done, because that was like the cool thing to do back then. Sometimes in textbooks, when something's proven like a definition, they'll draw a box and then like fill it in. You could do that. That just means done, end. Most of you guys, I feel like you guys would write a smiley face, because these are actually really satisfactory when you're done. Because sometimes it looks crazy, then when you're able to prove it, you're like, oh, I got it. Because it's like a puzzle, okay? So, well, however you guys want to show you're done, I'll let you guys choose. Okay. Questions on what I'm expecting so far? Everyone okay so far? Okay, let's do one that's a little bit harder. So it's all the same directions, verify the identity, so I'm not going to write it again. Sine squared of negative theta minus cosine squared of negative theta over sine of negative theta minus cosine of negative theta is equal to cosine theta minus sine theta. All right, so one thing, like the regular pre-cal class actually just started this too. So one thing students have been trying to do in that class is like multiply both sides by the denominator to make the fraction go away. You can't do that. You can't move things to either side. You have to just work with one side only. Okay, so obviously you guys agree this is a side that's more complicated, right? So what we're gonna do is we're going to rewrite this and rewrite this, because what I want you guys to remember is like sine squared of theta really means the sine of theta squared. That's what that means. Does that make sense? So, but it's not theta, it's negative theta. So I'm just going to rewrite the top. So it's going to be sine of negative theta squared minus, this is going to be the cosine of negative theta squared. All right. Now the bottom. Sine of negative theta. What do we know about the sine function? Is sine even or odd? Sine is odd. So the sine of negative theta is the same thing as what? Negative sine of theta, because sine is odd. So this is going to be negative sine of theta. Cosine is what? Even or odd? Even. So cosine of negative theta is the same thing as just cosine theta. So minus positive cosine theta is just minus cosine theta. Okay? All right, so this part's nice. If I take a negative and square it, do you guys agree this is the same thing as negative sine of theta? So if I square it, what's going to happen to the negative? This cancels, right? It becomes positive. So this is going to become sine squared theta minus cosine's even, but it doesn't matter because if I square it, it becomes positive. So minus cosine squared theta all over negative sine of theta minus cosine theta. All right, we did a problem kind of like this yesterday. This factors. This is a difference of two squares. It's kind of like x squared minus 4. We're all in agreement that means the same thing, right? So how could I rewrite this then? Yeah, sine theta plus cosine theta times what? Yeah, minus cosine theta. Okay. Now I want you guys to look at the bottom. Do you guys see how they're both negative? What could I factor out of that? A negative 1. I'm going to put negative 1 times sine theta plus cosine theta. And I did that on purpose because you guys noticed something. What's going to happen? You cancel. This and this are the same thing. So they're going to cancel out. So I'm going to get sine of theta minus cosine theta all over negative 1. If I divide both of these by negative 1, what's going to happen to them? Do you guys agree just the signs change, right? So this is positive. So if I divide it by negative 1, it just becomes negative sine of theta. Negative cosine theta is going to become plus cosine theta. And if I look back at the beginning, I know it's not in the same order, but do you guys agree that's the same thing? Positive cosine theta, negative sine of theta. So these are the same thing. So equals cosine theta minus sine theta. Put your little trademark, and you're good. Okay. Questions on this one? Okay. Another one. All right. Remember I told you guys sometimes there's different ways to do these? So I'm going to show you guys 2 ways you guys could do this one. Don't we have an identity that ties together a secant squared and a 1 in the same identity? What does that identity say? So I'm going to write this off to the side. One plus tangent squared theta is equal to secant squared theta, right guys? Now, if I want this, how could I change this so that way I get that? What do I have to do to both sides? Subtract 1. So then tangent squared theta is just equal to secant squared theta minus 1 if I subtract 1 from both sides. Does that make sense, guys? So I'm going to replace this with this because it means the same thing. Okay, so this is going to be method 1 of how you guys could do this. So if I replace the numerator with tangent squared, I'm going to get tangent squared theta divided by secant squared theta. Now, for this fraction, look at our goal, right? We want things with signs. Do I have anything with signs the way it's written right now? The way it's written right now? No. So I'm going to use that strategy, just change everything to sines and cosines and see what happens. So how can I rewrite tangent? Sine over cosine. But because it's squared, I'm going to write the numerator as sine squared theta over cosine theta. Sorry, cosine squared theta. And then the bottom, secant squared, you guys agree is the same thing as 1 over cosine squared? Is everybody cool with that? And then to multiply fractions, divide fractions, multiply by the reciprocal. So the top fraction stays the same, sine squared theta over cosine squared theta times, the denominator is going to become cosine squared theta over 1. And then what's going to happen? Cosines cancel. So what does this become? Sine squared theta is equal to sine squared theta. Okay. Questions on these strategies? Now, I'm going to warn you guys, these are going to look super easy when I'm doing them because I'm like prompting you guys of what to think. But when you're on your own trying to do these, sometimes you guys get stuck, sometimes you guys get frustrated, and that's okay. Please come ask for help. So I know I told you guys you don't have to do anything over spring break. I would at least look at this, try what you can, and bring me questions when you guys come back. Okay? All right. Here is a different way to do this. How many things do you guys see on the bottom? How many terms? There's just one term on the bottom, right? And there's 2 things on top. So what I want to show you guys is like, let's say you guys had something like this, like 2 plus 3 over 7. Can I rewrite that as 2/7 plus 3/7? And that means the same thing. So what I'm going to do is, right now I have one fraction, right? I'm going to break this up into 2 fractions. So I want you guys to see what happens. If I do that, so break into 2 fractions. This is just for your notes. You wouldn't do this like on a test. You wouldn't write that phrase. I'm just showing you guys for your notes. But if you guys break this up, what would the first fraction be? Secant squared theta over, oh my goodness, minus 1 over secant squared theta. What is this? 1 minus, what is that? Cosine squared. And oh my goodness, what's that? That's sine squared. Because remember, sine squared plus cosine squared equals 1. So this is just that, just rewritten. So this is the same thing as sine squared theta. Morning. You can move my backpack and put it on the floor.
All right.
Oh man, I tried to give you knuckles and you walked away. You're good. My class is making fun of me now. Okay. Questions? Okay. Let's look at example 5. All right. A problem like this is where things are going to get a little bit more difficult. Okay? So 1 plus tangent of u all over 1 plus cotangent of u is equal to tangent of u. Good? Okay. All right. Let's think through strategies right now. One strategy I've told you guys is to convert everything to sines and cosines, right? I wouldn't do that here because if you look at your end goal, obviously this side's more complicated, right? If you look at your end goal, you guys see how I want something in terms of tangent. If I change this to sines and cosines, I'm almost causing more work for myself because then I'll have to change it back to tangents later. So what's the relationship between tangent and cotangent? They are what? Reciprocals. So do you guys see how my goal is to change this just to tangent? So I'm going to change cotangent then to something with tangents. Does that make sense? What is this the same as? 1 over tangent. So I'm going to rewrite this as 1 plus tangent of u over 1 plus 1 over tangent of u equals. Mr. Vigil, this looks horrible. Now I have fractions inside of fractions. So much more fun, right? All right, this is what I would do. I'm going to leave this alone for now. If I ignore this, I'm actually going to get a common denominator on the bottom. So do you guys agree this is the same thing as just 1 over 1, right? So the LCD between these two is just tangent. So I have to multiply top and bottom of this fraction by tangent of u, okay? So the numerator of this mess stays the same. The bottom is going to become tangent of u over tangent of u plus 1 over tangent of u. Same denominator now. So now I can add the fractions, right? So I'm going to combine this into just one fraction. So the numerator stays the same. 1 plus tangent of u. Do you guys see how I made the fraction bar between the top and bottom a lot bigger? I encourage you guys to do that too, so that way you guys don't get lost in your steps either. So big fraction bar. And then you have tangent of u plus 1 over tangent of u. Okay. Do you guys see how this is a fraction on the bottom? How could I make the top a fraction? Put it over 1. So I'm going to take this and divide it by this. Remember, to divide fractions, just multiply by the reciprocal, right? So this is going to become 1 plus tangent of u over 1 times the reciprocal, which is going to be tangent of u all over tangent of u plus 1. You guys notice something? They cancel. Aren't these the same thing? Order doesn't matter because they're both positive. So, same thing, so they cancel out. So I'm left with just tangent of u over 1, which is just the same thing as tangent of u equals tangent of u. I'm looking at my notes from last year when I worked this out with the students, and we did this one also changing everything to sines and cosines. I don't know why I did that with them. They probably hate me. Don't do that. That's horrible. It's like a full page because you have to get a common denominator. Change this to sine over cosine, common denominator. Change this to cosine over sine, common denominator. Add the fractions, flip. Horrible. Don't do that. Okay. Questions so far? Okay. Now, these are when the real fun starts. Okay. Hey guys, which side looks more complicated? The left side. So what I'm gonna do, guys, is see how they're both fractions with different denominators? Whenever you guys see that, even though it's gonna suck, you need to get a common denominator and add things together. Because see how simple this looks? That means that some magic should happen when you guys do that, okay? So what would be the common denominator? Sine theta times 1 plus cosine theta. Okay? I know about half you guys had me and half you guys didn't have me. The way I explain this to kids is like, this already has a 1 plus cosine theta, right? What am I missing from this denominator so it matches my LCD? Sine theta, right? So I'm only gonna multiply by what I need, top and bottom. So I'm gonna multiply this fraction, top and bottom, by sine theta. So to make it so it's easier on myself and less steps, what is sine times sine? Sine squared. So this is gonna become sine squared theta over sine theta times 1 plus cosine theta plus, this already has a sine, right? So what am I missing? 1 plus cosine theta, so multiply top and bottom. So 1 plus cosine theta times 1 plus cosine theta all over sine theta times 1 plus cosine theta. Cool. Now this is where students get confused. And my Math 3 students are actually going to take a quiz on this today. Our goal is to add these, right? So even though it's really tempting, see how there's a sign on top, sign on the bottom? Do not cancel those, because then you're gonna go backwards back to this. That's not what you want, right? You wanna be able to add these. Don't cancel these. You're gonna add these now and see what magic happens, okay? So I have the same denominator, so now I can combine the numerators. So this is where the problem kind of gets annoying. Plus, I have to actually multiply all this garbage out. So 1 times 1 gives me 1. 1 times cosine is just cosine. Cosine times 1 is just cosine. Plus cosine times cosine. It's cosine squared. All over the same LCD. Sine theta times 1 plus cosine theta equals. Okay, are we okay? So, we're going to combine like terms, right? So this is where the cool part happens. And I want you guys to even fake smile, even if you guys don't think this is cool. Fake it till you make it, right? All right. Do you guys notice something on top? What? There's 2 cosines, so if I add those, I'm going to get what? 2 cosine theta? Do you guys notice anything else on top? Ready, guys? This is where you guys smile. What is sine squared plus cosine squared? 1. So this just becomes 1. So I have 1 in the yellow plus 1. What's 1 plus 1? 2. So this becomes 2 plus, if I add the cosines together, careful, because a lot of students will say cosine squared. If this was x plus x, would that be x squared? No. X plus x is 2x, so cosine plus cosine is 2 cosine theta all over sine theta times 1 plus cosine theta equals. Okay. Remember, what's my goal? I want 2 what? 2 cosecant theta. Do you guys see how I already have a 2? So that's we're on the right track. Because if I didn't have a 2, that's bad. And then cosecant is the same thing as 1 over sine. Do you guys see how I already have a sine on the bottom? So we're on the right track. What could I do to the top? Factor out a 2. So the GCF is 2. And oh my goodness. What happens? So I'm left with 2 over the sine of theta, which is the same thing as 2. When sine's on the bottom, that's the same thing as which trig function? Cosecant. Check. Okay. Questions? Do we hate this yet? Okay, we're making really good time, guys. So, I'm hoping to finish with at least 20 minutes left, so that way you guys can start your assignment and ask me questions. Okay? And if I were you guys, while you guys are in class, I would look at the ones that are harder, so you guys can ask me for help while you guys are here. Okay? All right. We just have a few more. 7. Okay, this one's a really important one because this is something that you guys may not think to do on your own. So tangent of x plus cotangent of x is equal to secant of x cosecant of x. Someone calling me. I have a question. Mr. Vigil, which side looks more complicated? They look kind of like the same, right? What side would you guys think would be more complicated? I would think the left side, because I have to add, and if we're thinking of trig functions, can't we technically turn any trig functions into fractions? What's more complicated, adding fractions or multiplying fractions? Adding, okay? So this is the strategy. What I would do is I would actually try to change everything to sines and cosines, because then that will help me figure out, I know this is the same thing as 1 over cosine and 1 over sine. So I'm going to change this into sines and cosines and see what happens. So tangent of x is the same thing as sine x over cosine x, plus cotangent of x is the same thing as cosine x over sine x. Okay, so please don't tell on yourself right now. If you guys don't know those by now, please, 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 please learn them. Okay. To add fractions, I must have what? Common denominator. So these don't have anything in common, so the LCD would just be sine x cosine x. So I'm going to multiply top and bottom of this by sine x. I'm going to multiply top and bottom of this by cosine of x. Is everybody cool with that? All right, so help me out, guys. I have the same LCD now, right? So I'm going to write everything over my LCD. So my LCD is going to be sine x times cosine of x. The top's going to become sine times sine, which is sine squared x, plus cosine times cosine. It's cosine squared x. Hey guys, what's that? It's 1. How exciting. All right. How in the world does that help me? Well, if I look at my goal, we know this is the same thing as 1 over sine, and this is 1 over cosine, right? And what am I doing with those? I am multiplying them. So what I could do is, if you guys have like, let me see, I'm gonna just do this, see if this makes sense. We know these are being multiplied, right? I could break this up as 1 over sine of x times 1 over cosine x. In a normal math problem, you guys would probably never do that, right? But these technically mean the same thing. You guys, does that make sense? And I want to do that because what is 1 over cosine the same as? Cosecant, right? And then 1 over cosine is the same thing as secant x, right? Is equal to secant x cosecant of x. Okay. Let's do another hard one. Any ideas? Convert everything to sines and cosines? Okay, let's do that. Can you imagine trying to change this to that? I don't know how you do that. My math teacher in high school used to mess with us and be like, yeah, let's start on this side, guys. I'm like, what? Okay, so what's this the same as? Sine alpha over cosine alpha, and this would be cosine over sine, okay? So the numerator is going to become sine alpha over cosine alpha plus cosine alpha over sine alpha. The denominator is going to become 1 over cosine alpha times 1 over sine alpha. These come up a lot in 3.5 and 3.6. So if you guys want more practice drawing those, they'll come up a lot. Because the formulas we're using have those all the time after spring break. I almost said after Christmas break. I don't. What month are we in? What month is it? March? Okay. Do you guys agree this is the exact same fraction we just added in the last problem? So if I get a common denominator, remember this became sine squared alpha plus cosine squared alpha all over sine alpha cosine alpha divided by, if I multiply the denominator of this big fraction, this just becomes 1 over cosine alpha sine alpha. Now, how does that help me? Do you guys notice anything? What happened? Hey, good. Do you guys agree this is the same thing as just 1, right? And then do you guys notice anything else? You can do that, but if you guys just look at this, isn't it this divided by this? Isn't this just the same thing as that, but just the order is different? So do you guys agree the numerator is the same thing as the denominator? So if I divide the same things by each other, what does it become? 1. So this whole horrible mess is just 1. Done. Okay. Couple more. I'm trying to find a hard one. So I'm looking at my notes I did last year. I don't like one of them I did. Okay. So I'm going to teach you guys one more strategy, and then we're going to do a hard one. We'll dive into calculus for a second, and then I'll let you guys work. So 1 minus the sine of theta over cosine of theta is equal to cosine of theta over 1 plus sine theta. Does anybody have their 3.4 homework? Can I see it real quick? Okay. Just want to make sure the problem I was going to give you guys is not on your homework. Can't be that easy on you guys. Okay. All right, so new strategy. Do you guys agree that both sides are like equally complicated? Okay, so what I would do here is just choose a side. I'm going to choose this side just because I want to. Why not? It doesn't matter. But do you guys remember, like, whenever we had problems like this, we'd multiply by the conjugate? So you would multiply top and bottom by 2 minus root 5 to get rid of this. We're going to do the same thing here. These we can multiply by conjugates too. So the conjugate of this, do you guys agree to be 1 minus sine theta? I'm going to multiply top and bottom by that, because watch what happens. So my equal sign is going to go here. I'm going to multiply this by 1 minus sine theta. Okay. If I distribute, actually I'm not going to distribute. Just kidding, I'm not going to distribute. And the reason why I'm not going to distribute and I stop myself is because if I look at my goal, do you guys see how I already have a 1 minus sine theta on top? And I just created a 1 minus sine theta on top. So I kind of want to leave these together, okay? So do you guys notice that in my answer there's no cosine on top? And I have a cosine here, so maybe I can manipulate this to get something with cosines. Okay, so if I multiply all this out, the numerator is going to stay the same, so cosine theta, 1 minus sine theta. The bottom is going to become 1 minus sine theta plus sine theta minus sine squared theta. These cancel because they're opposite signs. And then what I want you guys to notice is, do you guys see how on the bottom I'm left with this minus that? What is that the same as? Cosine squared. Wow. So this becomes cosine theta times 1 minus sine theta over cosine squared theta. So what happens with this cosine, with these cosines? It cancels out. So this is gone. I'm left with a 1. This, you guys agree, becomes just 1 cosine, right? Just cosine. So I'm left with 1 minus sine theta over cosine theta, which is exactly what I wanted. Okay. It should say example 10, just the formatting got messed up. All right. Sometimes you have to do both sides at the same time. And this is a good example. Okay. So what I'm going to do is just to show you guys like what the way that you guys would probably think when you guys are doing these. I'm going to work with the left side until I can't anymore, and I'll show you guys why. Do you guys agree that to add the fraction has to need a common denominator? So the LCD would just be this denominator times this denominator. So I'm going to multiply top and bottom of this by this denominator and multiply top and bottom of this by this denominator, okay? Well, what's nice is, see how the tops are ones? So if I multiply top and bottom by this denominator, anything times 1 is just itself, right? So the left side, when I write that, do you guys agree? Or you guys probably don't agree because you don't know. This means left-hand side, okay? Cosine of x plus 1 plus, I'm multiplying top and bottom of this by this guy. So plus cosine of x minus 1 all over cosine of x minus 1 times cosine of x plus 1. Combine like terms. Did you guys notice anything on top? The ones cancel. If I combine like terms on top, what do I get? 2 cosine of x all over. Is everyone comfortable if I just multiply this out for you guys and just tell you what it is? If you multiply all this out and combine like terms, some things cancel, you're going to get this. Cosine squared x minus 1. Now, where am I heading? I want this at the very end. So do you guys see I have a cosine and some cosines on the bottom? What's this the same as? 1 over sine. Do I have any sines in here right now? So I need to somehow create signs to show up in this. Okay, so this is where I'm doing this one on purpose because literally this one stumped my entire 7th period yesterday. The reason why I want you guys to look at this is because if you're not paying attention, you would say, oh, this is just sine squared x. And the answer is no. Because order matters. So off to the side, what I'm going to show you guys is, write this down. We agree that's true, right? What could I do to both sides of this to end up with this? Do you guys agree I could subtract 1 from both sides to get it over there? But then, do you guys agree I have to move this over there? So that means that cosine squared x minus 1 is equal to what? Negative sine squared x. So this is a good lesson to show you guys, please, I forgot the x, sorry. Please write this down when you guys do these so that way you guys don't substitute the wrong thing. So this becomes 2 cosine of x over negative sine squared x. Okay. And this is where a lot of you guys might get stuck. Okay? So, this is how you could show your work to work on both sides. You're telling me you're working on the left-hand side by doing all these steps, right? So now what I'm going to do is I'm going to write, now we're going to be working on the right-hand side. Which means my equal sign is going to go here, and I'm going to do all my work on this side to show you guys that I'm working on the right side now. The right side, what do we start with? Negative 2 what? Cosecant of x, cotangent of x. So let's manipulate that. This would be negative 2 times 1 over what? Sine of x times cosine x over sine of x. And oh my goodness, what happens to those? Negative 2 times 1 times cosine. Do you guys agree is just negative 2 cosine of x? What's sine times sine? Sine squared x. And do you guys notice something? They're the same thing. So what do we just prove? Therefore, left-hand side is equal to right-hand side. Check, done. That's how you can work with both at the same time if it's not so obvious of what to do. There are ways that you guys could break this up, but I'm noticing that students tend to get like this better. Because if you get stuck here and don't know how to change this to look like this, you can work with this until they kind of meet in the middle. Does that make sense? You end up with the same thing on both sides at some point. All right. The last thing I'm going to show you guys are some examples you guys might see in calculus. You guys will have a homework problem like this, but you guys will not have a test question like this. Okay. This says 11. Sorry, I got cut off. Tangent to the fourth x is equal to tangent squared x secant squared x minus tangent squared x. Which side looks more complicated? The right side. So this and this. Do you guys notice something? They what? They both have tangent squared. So what can I do with that? What? What can I do with that? Factor it, right? So where does it go? Outside. If I take out a tangent squared out of this, I'm left with secant squared x minus 1. Okay. I want to end up with this, right? So don't we have an identity that ties these together? What does that identity say? I agree. So if you guys look at our problem, how can I get this from this? Subtract what? 1. Good, good, good. So tangent squared x is equal to secant squared x minus 1. So then I could take this and substitute that in right there. Okay? So this is going to be the same thing as tangent squared x times another tangent squared x. So what can I do with the powers? Just add them. So this is the same thing as tangent to the fourth x. Done. Okay. Deep breath. Last one. Okay, I know you guys just registered for classes. You will not, juniors, you will not see anything like this next year. This doesn't come up till Calc 2. Any of the trig manipulation stuff wouldn't come up until Calculus 2, which is what you guys would see in college if you guys have to take Calc 2. Calc 2 is hard, but I loved Calc 2. It's because if you like solving stuff, you'll like Calc 2 because it's a lot of solving. But yeah. All right, so I'm gonna break my rule right now. Do you guys agree this side looks more complicated? I'm actually gonna mess with this side, only because I know what to do. And I'll show you guys why. Do you guys see how this is an even power? And this is not. I'm going to be clever and rewrite this. Because this is the type of thinking sometimes you might have to do in calculus. This is the same thing as, you guys agree, sine squared x. And then cosine to the fourth x. And then I'm going to rewrite the other sine of x right here. Now, if you're asking, like, why did I do that? Is anything different here? No, because what's sine squared times sine? Sine cubed, right? And then cosine to the fourth. These are all still being multiplied. I didn't do anything differently, but I just wrote it in a different way. Okay? So what I want you guys to notice, and the reason why I did that is because if I look at where I'm going, do you guys see how there's a sine of x at the end? That's why I did that. So now my goal is to change this to something with cosines and see what happens. So basically what I'm going to do is I'm going to isolate these two guys. What is sine squared the same as in terms of cosines? Yes, this right here is the same thing as 1 minus cosine squared x. Does that make sense? Class, does that make sense? Because that's one of our identities, right? And then if I look at where I'm heading, I already have a cosine to the fourth, right? So do you guys agree now I can distribute these? So what is 1 times that? Cosine to the fourth minus cosine squared times cosine to the fourth is cosine to the oh my goodness, we are so smart.